all of our elements that have multiple charges are cations. So they're going to come first in our naming system. So we're going to look at using these Roman numerals a little bit more. Okay? And we're going to kind of work from our compound backward. Okay? If I give you a compound that looks like this, we're going to try to name that compound. Okay? What name comes to you right off the bat? What do you think it should be called? Copper. What? Sulfide. Good. But which version of copper are we using? Right? Which one? Based on this name right here, do we know which one we're using? No. Because copper has multiple, right? So we don't know which one we're using because there's no Roman numeral included. So how do we go about finding which version of copper we're using? Okay? We do know what sulfide, what its charge is. Okay, so we can kind of look at it separately. So if we look at copper and sulfide, what is sulfide's charge? -2. And if we know that we have a balanced formula here, right, a 1 and a 1, or a 2 and a 2, or a 3 and a 3, right, those can reduce down to 1 and 1. If we know that this is a 2, what does copper have to be? +2. Good. So that means we name our compound copper 2 sulfide. So we can work backwards from our chemical formula to get the correct name, including that Roman numeral. Okay, does that kind of make sense? All right, let's try another one here. If I just told you, or if I just showed you this, right, what are both of those compounds tentatively named? Iron nitride, right? Both of these are iron nitride because it's a combination between iron and nitride. But they are two completely different compounds. They behave differently, they look differently, they have different ratios of iron to nitrogens. Okay? So we have to look at, these are two different compounds. So the first one, iron nitride. This one is iron nitride as well. But there's a difference because we are using two different versions of iron. So in our first compound, right, we can always reverse these back up, right, and that would give us Fe plus 2N minus 3, right? Right, you can just reverse that crisscross method when our subscripts are there. Okay, so that means this is iron what nitride? Iron 2. Okay, now in our other version, we don't have any subscripts. That means they have to be even, right? They have to have matched somehow for our subscripts to reduce down to 1 to 1. So they must be balanced. And we know nitride has a charge of what? -3, which means iron has to be what? A +3. So this one we're iron 3 nitride. Okay, so do we see how that one different electron for iron makes a huge difference in terms of the molecule that we're looking at? Okay, it's really important that when we write our final chemical formula, we don't include charges in our chemical formula. Okay, we should never have charges or superscripts in our final chemical formula. So Fen would be our final formula. We don't show charges ever. We don't show Roman numerals ever in our formula. We show Roman numerals in our written name only. Okay? Does that kind of make sense? Okay. Let's try a couple on your own here. Give me the written formula for and give me the chemical formula for this. Okay, so you're going to give me the name of the first one and the chemical formula for the second. Okay, do we have anyone that wants to volunteer their written name for their first one? Yeah, Ethan, what'd you have?
I have lead 4 sulfate.
You had lead 4 sulfate. Okay, how many people would agree? Okay, where's the 4 coming from? Lead 4 is not quite what I had. What do we think? Yeah, Kat. Lead 3. Okay, so even though it's not one that's listed on our periodic table of ions, that's okay. Okay, and here's where our 3 comes from. We know that sulfate has a charge of -2, right? And we don't know what lead's charge is, right? We're trying to figure that out. So if we have 3 of these, right, that would give us a -6. And we know we have 2 of these leads. So what times 2 gives us a +6? Right? A +3. You could also just crisscross your charges back up, or your subscripts back up. Right? And that would give us a -2 and a +3. And you can do it either way. But we should have had lead 3 sulfate. Okay, how many of you got that? Okay, good. Good. SNO2. Do we agree? How many of you had this? Can these 2 be reduced? Yes. Okay, so we can reduce them. As long as this subscript is not part of a polyatomic ion, which neither of these are polyatomic ions, we can reduce them. We would never change a subscript within a polyatomic ion. So you're never changing sulfate, from SO4. You're never changing phosphate from PO4. You're never changing polyatomic ions, but those can be reduced.
So let's say you were to put the bottom one on a test without reducing it. Would it be wrong?
So ionic compounds have to be reduced. Okay, give me the formula for that. And the name for the one below. Okay, Megan, why don't you tell me what you had on the first one? Like that? Okay. Couple things that we need to fix. Can anyone tell me one? Yeah. Iron needs to go first. So why is that the case? It's the cation, right? So we should always work left to right on our periodic table. Okay, so the cation always goes first and then the anion. Okay, so we should have FeOH3. Anything else we need? We need parentheses. Good. Right, since we knew that iron was a +3, hydroxide is OH -1, so we need 3 of those. Yeah, Thomas, what'd you have?
Chromium 2 bromide.
Chromium 2 bromide. Agreed? Yes, perfect. That's what I had. Chromium 2 bromide. All right, very good. I want to try one last one here with our polyatomic ions, just reviewing those parentheses and how they work. So I want you to give me the chemical formula for calcium phosphate. Calcium phosphate. Does calcium need a Roman numeral? No. So only elements with multiple charges need that Roman numeral. Don't tack them on for every single one. Okay, we only need them for multiple charged elements. Calcium phosphate. Phosphite is one of your polyatomic ions you want to memorize. Here's a trick for our polyatomic ions. If you can memorize the 8s, you know what phosphate, sulfate, chlorate, if you know what those are, if you know what the 8s are, the ites is just taking away one oxygen. That's it. So phosphate is PO4 minus 3. That means phosphite would be PO3 minus 3. The charge doesn't change. The only thing that changes is you have one less oxygen. Okay, so if you can memorize the 8s, you'll know that the ites are just one less oxygen. Okay, calcium phosphite. Alexa, why don't you tell me what you had? Raise your hand if you agree. Perfect. Okay, I agree. Okay, so let's break down how we got there. How do you know when to put the parentheses? Yeah. So we have, let me start it kind of from the beginning here. Okay, calcium is a +2. Phosphite is a -3, right? Would you agree with that part so far? Okay. So if I cross down my charges, that leaves me with Ca3PO3 2. So since we want the 2 to refer to the whole phosphate molecule, that's why we put the parentheses. So we know we just don't need 2 oxygens or 2 phosphorus. We need 2 of the whole thing. So we put parentheses around that polyatomic ion showing we want the 2 to go to the whole molecule. Does that make sense? Okay. If we had a subscript like where it was just a 1 for phosphite, we don't have to include the parentheses. We would just leave it off. Right? But since we need to have 2 of those phosphate molecules, we include that too. Okay, and the parentheses.